So let's start, guys. First of all, let's make a new geometry. Let's get inside it. Let's make a planar patch. Let's choose top seam to have a group of the upper point. Then let's make a Vellum configure class, and let's make a Vellum solver. Here let's choose the group that we made, and we can check it here in the Vellum solver. Yep, here they are. Okay, don't need to see it. So let's make a, let's say 10. Let's hit play. As we can see here, we have little stretching. Let's increase the substep to 5 to have more accurate result. Maybe I will change it to 10. Okay, now let's check what we have here. We will talk about the mesh. Okay, by default it give us a calculate varying, but let's choose unchanged first. Before that, let's make a spreadsheet. Let's choose hide all. Let's choose the mesh. As we can see here, we have a value for the mesh for every point, and it's all are different. Okay, so let's see if we choose the unchanged. As we can see here, unchanged, as it said, the Vellum constraint will not affect the mesh itself. So for example, if we make a attribute triangular and we set here if at mesh equal 1, for example, as we can see here, Vellum wouldn't change it, and even it doesn't have a scalar. Okay, so this is first. Second, we have something called set uniform. So as we can see here, no matter what the value that we have for the mesh, for example, let's make it 2, still we have here 0.1. So this is if we want to have a specific point, a specific value for the mesh. Okay, next let's make a calculate. But of course, this one, if we hit play, as we can see, it will close too much because we have a big mess. Let's hit play again to see. Okay, so even if we increase the number of the edge length, the point, it will even fall more and more, because now we have a much bigger mess, right? Because every point counts and it make the mess heavier, so it's normal will fall down, right? So let's check something else, which is the calculate uniform. So let's see if we have here our spreadsheet again. As we can see here, it totally changed it. Let's hit play. So as we can see, it's almost not change. So basically, calculate uniform, it calculates the best value for the mesh. Okay, so it wouldn't change. So let's see, let's say example, we will increase this even more. As we can see here, the mesh become much bigger, and it gives us the same result. As we can see here, even after we make the size even bigger, let's say 3 by 3 by 3, not 33. Okay, not 33, only 3. So even after we give it a massive scale with a massive number of points, still it will give us the same result. It's almost the same result, right? Or it's the same result. Okay, so but there is something bad about this method. I will tell you. Let's for example make this 0.5. So basically it work on the uniform, okay, on the size. But let's say let's delete this one, we don't need it. Let's say we will have another planner here. Let's make a merge between both, and let's move this a little more. Let's say center will be 2. Let's hit play to see what we have here so far. Okay, I'm not sure why. Yeah, okay, it fall because this one doesn't have a, yeah, actually it has a Steam. I think I should also, yeah, this is 1 and this is 2. Okay, so we have those two both. Let's increase, maybe reduce this number 3. Let's see, still the same. I think it's all still the same. Okay, so, and of course it change all this here. If we say only show selected, this one, yeah, let's choose the point, this one, or this one. It doesn't show me the mass. Yeah, as we can see, the value is different between this and this. And also it work by the connectivity, because it only calculate every object which have same connectivity. I mean this object and this object, so it can separate and know which one. They are both two different objects. Okay, but there is only a problem about this method. If we, for example, try divide here, and for example let's select this side here, hit enter. Okay, and let's start it to increase it. It will be like this. Okay, so let's hit play to see what we have. Yeah, okay, so let's make it maybe 3. Okay, yeah, as we can see here, this one becoming heavier than this one, than this side. Let's see if we can hit by this thing by 5. Yeah, so even after we increase the density is a scale for the mass, just a scale. Okay, so as we can see here, it doesn't work with it's only work with polygon that has even point, right? But this object now doesn't have an even point, so this point is much more than the other, right? So this method will not going to work. So let's choose the other one, which is calculate varying. Yeah, so as we can see, it's supposed to working. Somehow I feel this still a little heavier, but this the calculate varying, it calculate every point separated. So let's see if we check the spreadsheet sheet. This one has a different value than this one. So if we make it calculate uniform, this one, as we can see, both are the same, but this one is different. Okay, so yeah, let's make a primitive. Also we can, as I said earlier, we can multiply it by density, even by scale attribute. We can use this one. If I take this one, I will delete this one for now, don't need it anymore. Yeah, okay, so let's make attribute paint. Let's put this one here, and let's make a fill. Yeah, let's make a, all will have same density, but of course not this one. We need to copy the density here and paste it there. Yeah, okay, let's give it another shot. Then we'll choose surface. Let's choose 50, and then let's draw this one here. We wouldn't see it, but if we go to density, we go to minimum, maximum, let's put here 50. As we can see here, we will see it like now. So let's hit play to see what we have so far. As we can see here, the density even make this part much heavier. Okay, so let's go to the spreadsheet again to see the mess. Okay, yeah, because I choose yeah, okay, here's the mess. Point. So this is the density, as we can see, and this is the other parts. So it's hard to say if it's changed or not, but looks like, yeah, it changed. So let's make another geometry. Let's make a test for now, like this one. Okay, um, then let's give it a Vellum configure cloth, and then Vellum solver, hit L to lay out everything. Okay, let's check what we have next, which is drag force, normal drag and tangential drag. What exactly is normal and tangential? As we can see here, if we can check this test, if we hit this button, we will find this is the normal. Okay, so basically the normal is a line perpendicular on the primitive, as we can see here. Okay, so basically this is the normal, but what is the tangential? Let's make a poly frame and let's check what is the tangential. So as we can see here, let's just control it a little more, maybe something like this, and uncheck this one. So basically the tangential is a line in the direction of the surface itself, meaning let's imagine we have a drop of water. This drop of water, when it fall on a surface, it will run through it, right? So basically this is exactly same as the tangential. It's just a line that run through the surface itself, take the direction of the surface, as we can see here. Okay, so basically the where is it? Yeah, so basically the normal drag and tangential drag is a drag force that this one depend on the normal, and this one depend on the tangential, as we can see. Let's say if we want a planar patch like this, and we simply add it like this, and this one, let's make it xz. Okay, what exactly is the drag force? Drag force is same as the drag force in the pop force. Okay, simply it can make a drag force while any object is falling down. For example, if we make this one 0 and let's hit play, this one will fall as if it's just a plate of sheet or something. It doesn't, there is no reaction on it. Okay, even it is a cloth, it has a bend and stretch and all this stuff. But let's say if I give it like 1, let's see again. Okay, let's give it a 10. Yeah, so basically as we can see here, the drag itself, it's slow the planar when it fall down. Even if we give it a mountain to see it a little better. Okay, again, if I make it 0, let's see what's going to happen. It will fall without any change on its shape, right? But if we, for example, add 1, let's see again what's going to happen. Yeah, so as we can see now, it started to change its form, as we can see here, like something falling on the air, right? And even if we make it 10, so it will be much slower, like it's falling in the water or something like this, right? So basically, if you want to make a cloth effect falling in a water, in a fluid, we increase the drag, wind drag. Okay, let's make it back again for 1 or even 0.1. So what exactly is let us add something here. Let's add I'll make this 0.5 for now. This is first. Second, let's give it edge fracture, and let's check the pieces that we got here. Yeah, so here is the pieces. We will increase it maybe to 20, or maybe let's say 50. Okay, so basically when we say normal drag is 10, that means we have 10 value on the normal drag. That means it's not going to move through the direction of the normal, while the tangential drag is 0.1, so it will move more when it fall, or when it affected by any force in the tangential drag mode, because here we don't have almost any drag, so it will move freely in the direction of the tangential. So let's check. Of course, if you want to check, we have to stand. Yeah, so basically it just uh, fly on the direction of the tangential itself. Okay, so if we say this 10 and say this 0, let's see. As we can see, it fall like someone just fall from the sky or something, right? Just falling on its direction, on the direction of the normal itself. So this is the difference between both of them, the drag, normal drag, and tangential. Let's say this will be 1000. That means we don't even, the drag force will be much more. Yeah, so basically this is the difference between both of them. Maybe we can make 10 and 10 and see the result, how it's gonna be. It just fall, so basically when we make it 0.1 in the tangential, it gives us much better result, very interesting result. Okay, we can even make another planar like this, make this planar like this, and let's see the planar that we have here. Okay, so basically I think we have left steam. Let's choose the left steam, and I'm sorry the mouse is not very smooth. Let's make it maybe 0.1, and let's increase the force, the wind in the x direction. Okay, maybe the wind will be 10. So let's see what we have here. Yeah, so let's say if we have 20, and also let's make the stretch even less, something like this. Yeah, this is too much. I will just make it 0.1. Yeah, so let's see now if we change the drag force. I will make this one 0 and I will make this one 10. Let's see the result now, how it's gonna look like. Yeah, as we can see, just something stretching, but really it doesn't have any. It's little boring, right? Just a boring simulation. So anyway, this is the difference between the normal drag and the tangential drag.